Yeah, hi, good evening, everyone. So, welcome to Week 3 open session first. So, I hope you have started watching the lecture of Week 3. And if anyone have any doubt before starting the session, then you can raise the hand and I'll ask one by one. Anyone have any doubt in Week 3 or any week before that? Because Week 2 is done, now Week 3 is going on in this week. Any doubt in regarding any topic, and like programming assignment is also live now from the Week 3. So any doubt in programming assignments, interface? Okay. So I think no doubt. So let's. I'm starting with the topics of the Week 3. So meanwhile, if anyone have any doubt in the topic, so you can ask us. Okay. And so I think someone is raised the hand. Let me check. Yeah. Good evening. Yeah, Mihir. Go ahead.
Hello, sir. Good evening.
Good evening, Mihir. Yeah.
Sir, I have some basic doubts in week two, if I can ask like that.
Week 2. Yeah, please. Ask. Yeah.
Yeah. So, first is what are exactly standard libraries in terms of Unicode? Uh, sir had mentioned some reference about this sentence, but if you can just elaborate and clarify.
Standard library. You are talking about the Unicode.
Yes, sir.
Okay. So Unicode library. So library. I think Unicode is itself a naming convention. I'm also not sure. One second. Okay. So is it mentioned anywhere library? Because library terms I'm not able to recall in the Unicode, because Unicode itself is a this naming convention, like what character we are using and corresponding what code is there. So
Okay.
Unicode itself is a actually library,
Okay.
we can say.
I guess there was one sentence which he said that it is advisable to use the standard libraries. Uh,
Okay, okay. So regarding program, I'm not sure because this is not used in C. Okay, so we have to check this. I'm also not sure right now. So which library actually we can use at the time of the programming regarding this Unicode things. Otherwise, Unicode actually contains this encoding things, lots of uh, different characters which we generally used in the text.
okay.
Okay, so
Sir, it is in the video. The reference is in the video titled Character Representation and Encoding.
yeah, that I'm saying. So character representation. Uh, First thing, ASCII things. Okay, so ASCII encoding, we know that what is the ASCII. So ASCII is also representation of the characters in the binary form.
Yeah.
Okay, so where we represent the each character in the 7 bits.
Okay.
So but that ASCII have some limitations, so that not contains the representation for every character. So now the time to times these characters are increasing. So this is not limited to only just English letters and this numerical letters. Now the language is also coming, like this Hindi or any another language. So how these characters can be represented. So because of that, this Unicode actually comes, that also that contains the lots of characters encoding. So if any time in programming language it is required, then we will think that what are the corresponding libraries are there. So otherwise, it is not used most of the time. So right now, I am also not sure about any specific library
Okay.
which will be useful in the programming language. And this is also not too much important for this course, actually, specific course, C programming.
Okay, got it.
Yeah, Indumati.
Sir, can you explain that sign magnitude around one time? What is sign magnitude?
Sign magnitude. Okay. Okay, one second. Yeah. So actually, sign magnitude means we have some numbers actually that can have some sign included with this. Okay, so like if we have any variable like a, and that contains any value like 10. So this 10 is basically a positive integer. Okay, and for any variable, suppose we want to store only the positive value and there is no negative value possible for that. So like age. Okay, so age is a that characteristics that only contain the positive values, no negative values. So in that type we can assign a only unsigned variable for that, because that cannot be a negative. We will always store the positive value. uh, but some
Sir, can you give an example with negative value?
negative
Like
value
if
you
we
can
take
take
any hexadecimal number and they're telling us to find the sign magnitude of that, will it contain negative as both? Like, can you give an example and then?
so that I'm taking, if suppose we are taking for any if you are writing any program for any problems and that problems contain the negative value like minus 10. So how this value actually will represent in the computer? This is negative number. Okay, so here we have also stored the information that this is a negative 10. This is not a positive 10. So here this means this variable a, that is actually storing this negative value, that may also be stored sometime positive value. So in that case this variable should be a sign variable, because that is containing the both type of value, negative and positive value. Okay, so in that case we have to represent this number with sign. So sign information will also be stored in the computer, so that to represent that this number is a negative or positive. Okay, so in that case
Okay, sir.
how we can represent this negative representation? Suppose minus 10 we have, then how it will represent? So actually in the professor have discussed two methods. We can simply represent sign magnitude or sign value. So like 0 0 for, I think, positive, and 1 for negative. So most significant bit. So suppose if we are representing this 10 decimal value in the 8 bit number. Okay, so like how it will represent? So what is the equivalent binary for 10 is 1010. So this is the equivalent binary, and we have to take 4 more bit for this, because we are representing the data in 8 bit. Okay, so this is negative, so that means we have to represent this with most significant should be 1. So now this bit actually is representing the sign. If this most significant bit is 1, that means this is a negative number. If this is a positive, then we will represent like this. So 0 0 0 0 1 0 1 0. Okay, so this is for negative 10.
Like if we take minus 15, then it will be 100 111.
Yes, 1111, 4 times 1.
Yeah, 4 ones at last.
Yes. So this is sign
Okay.
magnitude. Other representation professor discussed like this 2s complement representation. Okay. So what is the drawback for this? What is the drawback for this representation is? So suppose we have the range. So like 0. So, we are representing the number only this 8 bit, but we are using 1 bit for the sign and another 7 bit for number values. Okay, so what is the range to represent this value? Okay, so range 0 to we have total 7 bits. So 7 bits means 2 to the power 7, and this is 128. Okay, so 128. So if we are starting from 0, so this will move to till 127. Okay, 127. But what is the equivalent representation for this 0 is in the sign magnitude? Okay, that is actually positive. Zero,
Introduction.
zero, 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 0000. Okay, this is the equivalent number. If we are writing this, and same time, yeah, if someone is not asking any question, turn off the mic.
அவங்க இது எப்படி ஓபன் பண்ணது தெரியல எனக்கு.
Okay, so this is the equivalent of 0, and first bit we are using for the sign, so this is representing like a positive. Okay, so positive sign. But same things we can also represent a number with 1. Okay, so 10000 and 000. Okay, so now this value is representing a negative sign, and this is the magnitude also is representing 0. Okay, negative sign and 0. So minus 0 and plus 0, we have the and after that we have the negative representation for all the value till minus 27, 127. Okay, but in this representation we are getting two representation for 0. So this is one and this is second representation. Both are representing 0, and one is with sign plus and another is negative sign. So but this is not the correct representation, because 0 have no sign actually. Okay, so this 0 should be represent with the only one value. Because of that, another representation is used actually, that is 2s complement. 2s complement to represent the negative number. So suppose if we have 10 numbers, so how we can represent in the 2s complement? So positive value will represent as it is. Okay, like as the previous. So suppose we want to represent 10 in the in 2s complement, so that will represent in the same manner. So 0000 and 1010. Okay, this is the positive representation. So that means 0 to this 127. Okay, this will represent as the as it is in the positive range. But for the negative range, suppose if we want to represent the minus 10, so how we will represent this in the 2s complement? So first things we will write this, we will use the positive representation for this. So this is 0001010, and we will convert into a 1s complement first. So 1s complement is just if you reverse all the bits. Okay, so 0 to 1 and 1 to 0. So what is the 1s complement for this is 1 1 1 1, and this will become 0 and 1 and 0 and 1. So we have just reversed all the bits. Now this is 1s complement. Now, and we will add one bit for the 2s complement. We will add one bit in the that least significant bit. So 1 1 0, and one carry will come here, so that is 1, and now all will remain same. So 0 1 1 1 and 1. Okay, so now this is the 2s complement for this 10 actually. Okay, so 10 value. Now this value will be considered as a negative 10, because here the first bit is representing 1, and this remaining number will represent as a negative 10. So what is the equivalent value for this? Yeah, so this is the minus 10 value. Okay, so first thing minus 10, this is the minus 10. But what is the actual magnitude if you calculate it for this? So this is sign is representing the negative, but this is in the magnitude is 1 1 1 0 1 1 0. So what is the value for this? Okay, so this is 2 to the power 0, 2 to the power 1, 2 to the power 2, 4, 2 to the power 5, 2 to the power 6. Okay. Oh, 0 1 2 3 4 5 6. Okay, yeah, so this will become 2 plus 4 plus 2 to the power 4. Okay, 16 plus 32.
It will be a large number.
Plus 64. So 64 and 32, 96, and 102 1 1 12, 116 and 118. Okay, so that means this minus 10 is actually equivalent to this 118, if we not consider this, and we if we included this, so let be 128. So 118 is 128. 6, 1, 2, 3, and 4 and 2. So 246. Okay, so what is the decimal equivalent for the complete value? So this is 246. So that is actually representing a minus 10. Okay, so in this case, yeah, so in this case, you will not get the 2 representation for 0. Okay, so the 2s complement is actually we use the different calculation for the negative number. So we use the 2s complement for any value. So if you want to calculate and like what is the minus 50, so just first check what is the binary equivalent for 50. Okay, and then convert that into a 2s complement. So that will represent as a minus 50 value. So
Okay, sir.
these are
Understood.
to
Thank you.
represent. Yeah. Okay.
Yes.
Yeah, Nikhil. Next is Nikhil.
Sir, I have a query on
Mm-hmm.
practice assignment 6, which is about coding
Practice
related to.
assignment 6 of Week-3. You are asking?
Yes, sir. Yes, sir.
And theory and programming.
Sir, programming actually, what formula I use in this for power 1 plus r power n.
Haha. Okay. Let me open the question. Okay. So you are asking practice assignment question number 6 in the
Yes, sir.
Week-3.
Yes, sir.
This one.
Sir, what formula I use for solving this?
So formula is given here.
For um, at coding 1 plus r power n.
Okay. You are saying that how we can use this power things.
Yes, sir.
Okay, so there is one math library that is included in the code. Okay, so you can see this has included math.h. So
Yes, sir.
you can directly use the function of this math library that provide this math things. Okay, so math power things. Okay, let me
Okay, sir.
write this. Suppose if you want to calculate first things, because we want to use the direct function of the math library, so we have to include that header file in our program. So that has include and the math.h. Okay, after that, suppose if you want to calculate the power for any value, so what we will do, we will write like this. So like int a equal to 2. Okay, and suppose we have another variable int b, and we want to calculate the value of b like this. So b equal to POW. Okay, and a to the power like 3. Okay, so comma 3, and print the value of
Okay, sir. Okay, sir. I understand.
yeah. So that b. Okay, so you can see
Okay, sir.
it. So this function you can use from the math library.
Okay, sir.
Yeah. Next is Ananda Sri.
Good evening, sir.
Evening, yeah.
Sir, I have a doubt. How to use the if-else statement, sir?
Okay, so if else statement, conditional statement not discussed in the Week-3, so that will discuss in the Week-4. But
Okay, sir.
I can explain this. Suppose, so is it used in any program? Because we have not used, because it is not discussed.
No, sir, it's not used, but I tried something, but it's showing error. It's not running.
Okay, so let's we want to check that if number is a even or odd. Okay.
Yes, sir.
So let I'm taking one variable int a equal to or you can say n equal to 10, and we want to check that this n number is even or odd. So how we can do with the help of this if else condition. So first thing, the statement is we use like if condition, and inside the bracket with the if, we check the condition to check this number is a even or odd. So how we can check? We can divide the number by 2 and check the remainder. If remainder is 0, that means number is even. If remainder is 1, then number is odd.
Yes,
Okay. So what we can do, we can write like this n, and this is the sign for to return the remainder. This is the operator. Okay.
yes, sir.
So 2 2 equal to we can check 0. Okay. And after that we are just using this block. So that means what we are writing here, if this condition is true, this is a condition. In this condition we are calculating the value n divided by 2. This is operation for the remainder signs, but it divides first and return the remainder value. So here n divided by 2, and what is the remainder? Okay, if that remainder is equal to 0. Okay, equal to means we are comparing the value. If both left side and right side value are same,
Yes, sir.
that this expression will return true. Okay, that means both value are same.
Yes, sir.
One second. One second. Yeah, sorry for interrupt. Okay, so so if this condition is true, that means the block of which we are written in here,
Number is
so
even.
that will actually execute printf. Yeah, even. We are just writing even. So this even statement will print even. Okay. Otherwise, if this condition is not true, so we use the else statement. So else. Okay, and we write the statement for that. If the condition is not true, this else part will be executed. This part will be ignored. So here we are writing the odd. Okay, so
Odd.
that is odd. Okay, so now if we run this code, you can see even number we are getting, because this 10 is divisible by 2 completely, and
Yes.
we are getting 0. If we change this to 11, you can see the statement will, this statement is executing odd. Okay, so that means this condition we are checking. If this condition is not true, we are that compiler is directly jumping to the else statement, this part.
Yes, sir.
If this statement is true, that compiler is entering for this part. At a time, only one statement will execute.
Yes, sir.
Okay, so this is the simple state structure of the if else condition. So we will discuss this in detail of in week 4 basically.
Okay, thank you, sir.
Okay, yeah, Bipul, go ahead. Bipul, oh, Bipul is asking in the chat. Okay, one second. Sir, what is the minimum number of bit required to represent 5 numbers? Okay, so is this question belongs to any graded? Uh, so graded deadline. Let me check only. 19. Okay, so yeah. So do not ask the question which is directly coming from the graded assignment. Okay. So what we can do, we can discuss the another type of questions for this. So because the deadline is still not over for this, so let me just discuss. So regarding this type of question, suppose you have total different types of unique characters, 25 characters. Okay. So how many bits are required? Minimum number of bits are required to for represent this 25 different characters. Okay. So suppose if you have two characters, that means how you can represent this two characters, how many bits are required. So that means one bit you can use for this, and that bit will if that bit is 0, so you can represent one character, and if that bit is 1, you can represent the second character. So that means for two characters only one bit is required. Similar for the 25, or let's move to the 4. Okay. So for 4 characters, so how many bits are required? Because bits we can only use 0 and 1. So 0 and 1 value we can use in the binary. So how many bits are required to represent 4 different characters? So you cannot represent with the help of one bit 4 characters, because that bit value can be either 0 or 1. So you have to include one more bit to this. So like you can take 2 bits.
Sir, represent 25, 16 bits are required.
Or 25. No.
Yes.
16 is not required. I'm just telling you. So for 4 characters, so how we are deciding this? So what we can do, we can take 2 bits, and 2 bits for like 0 0. We can take so what? How many possible combination for 2 bits? So 0 1 1 0 1 1. You can see these are the only combination if you are using 2 bits. Okay, and for each combination you can represent one character. So 1 2 and 3 and then 4th character. Okay, so you can represent the 4 character with the help of 2 bits. So we can create a formula for this. So that means if we have 1 bit, so how many characters we can represent? That means 2 to the power 0, and that will be 2 to the power 1 if you have 1 bit. Okay, for 1 bit total 2 characters can be represented. For 2 bit, just use the same formula, 2 to the power 2. Okay, 4 characters can be represented. 3 bits, 2 to the power 3. Total 8 characters can be represented. Okay, so 4 bits, total 2 to the power 4. 16 characters can be represented. 5 bits, 2 to the power 5. 32 character can be represented. Now here the value is 25. So you want to represent 25 characters. So 25 character cannot be represented in the 4-bit, because you are getting 16 representation if you are using 4-bit only. But here, if you move one more higher, so if you are using 5 bits, so you can you can represent 32 characters with the help of 5 bits. So this means this 25 is greater than 16 but less than 32. So that means it's for 25 you need at least 5 bits. Kam se kam. Okay. So 5 bits are required to represent this 25 numbers. So this is the minimum requirement. You can also represent this 25 character using 6 bits, 7 bits, but this is the higher things. But if we are asking what is the minimum number of bits are required, so this is the minimum number of bits required to represent different 25 characters. Now you can calculate your question. So how many bits are required? Is it fine? Hello? Okay. Let me open. Yeah, Kabilan.
Yes, sir. Good evening, sir.
Good evening. Yeah.
Sir, 2 weeks before I had asked on the discourse forum, sir.
Mm-hmm.
So I then you said to contact the support team, sir. I contacted them, sir. They're saying it's working for other students. Please check, but it is still not working for me, sir. I mailed them again. They're not responding now.
No, what is not
Can you
working for you? Forum or what? Can you repeat?
Yes,
What
sir.
is not
The
working for you?
discourse forum is like not accessible for me, sir.
Okay, you are term students.
Foundation students, sir.
Foundation student. Okay, okay. You have already cleared this qualifier.
Yes, sir.
Okay, you are not able to access the C programming forum. Okay. Can you
Yes, sir.
just
Actually,
send?
both.
Yeah, can you send your email ID in the chat?
Yes, sir. I'll do. So that.
Yeah. Yeah, I'll check with the option. So they will add you.
Yes, sir. Thank you, sir.
Okay. Yeah. So okay, next is yeah, Ramji Gupta. Yeah, Ramji, do you have any query? Okay, Aniket
Good
was.
evening, sir.
Okay, okay, Ramji, yeah, go ahead.
Can you
Yes,
listen
Ram.
me?
Yeah, yeah, go ahead.
Sir, I am asking week 2 practice assignment, question 5, 7, 8, and 12.
Okay, 1 second. B2.
Practice assignment.
Okay, so practice assignment. Now tell me the question number.
5,
Okay, 5,
7, 8, and 12.
5, 7, 8, and 12. Okay. So first 5. Okay. So which of the following assembly level instruction can be used to store a value of 0 in a register named R2? Assuming R0 is always holds the value 0 and R1 always holds the value 1. So R0 actually stored this 0 value, R1 have this 1 value. Okay. And we want to finally store the value 0 in R2 register. So this is our goal. So R2 store R2 registers we want to get 0 value. Okay. So which instruction actually performing this task? Okay. So if we say that first statement move mov r to 0, so the meaning of this is that the value of the last operand, so this is called as a operand. Okay, this is a instruction. The first statement is a instruction and another are actually operands. So the value of the last operand is actually moving to the register R2. So if we perform this instruction, so this is moving the last operand value that which is 0 to R2 register. So that means we are getting our purpose fulfilled here. So this first operation is actually storing the 0 value in R2 register. Okay, so this is our final goal. And next is second instruction add R2 0 0. Okay, so this instruction okay, let me check. Add R2 0 0. Okay, here also, so same things we are performing 0 and 0, these two value we are adding and storing into R2 registers. So this is the another operation that doing the same things. So 0 and 0 it is adding now and storing the result of this calculation into R2 register. So 0 plus 0 is 0. So, same things we are getting R2 equal to 0. So this is also fine. And next is sub to R2 R1 minus R0. So sub means subtract. Subtract the value of R0 from R1 and store the result into R2. So this is the meaning of this operation. So what is the value of R0? 0. Okay. And what is the value of R1? 1. So 1 minus 0, we are getting 1. Okay. and that one result we are storing into R2. So R2 now we are getting 1. So this is not our final code. So this operation is not performing our final task. And ADDI R2 R1 0. So this is also the similar instruction of the add thing. So here we are adding the 0 value in R1 register. So what is the value of R1? 1. So 0 plus 1, we are getting 1, and that 1 will store into R2. So we are getting R2 equal to 1. So this is also not performing our final task 0 in R2. So only the first two instructions are actually we are getting the final 0 value in our R2 registers after performing. Okay, so these first two are correct. Next, you said that 5 7.
Sir.
Yes.
Sir, doesn't ADD alone mean add, sir? ADDI means like there's nothing called like that, no, sir.
Okay, 1 second. What you are saying, ADDI means, so this is add immediate. This is
Add
the meaning.
immediate.
So I means is here immediate. So what is the value of the last operand actually in the previous add? Both are the operand, not registers. But here we have the registers, and the last
Okay,
operand
sir.
value will be added into the registers. This R1.
So when there's a register, we should do ADDI, sir.
What you're
Sir,
saying? Yes.
whenever there is a register in the operand, we should do ADDI function, sir.
So that is some difference are there, but the meaning here is actually we are adding some operand value, which is 0 1 anything, into the registers value. Okay.
Oh,
So
okay, sir.
some difference are there. So you can just search what is the difference between add ADD and ADDI. So you will get the exact
Okay, sir.
difference. But here the meaning of this is we are not using the registers in the ADD. Okay, for the operand, we are using the value directly.
Okay, sir.
So
Thank you, sir.
Sir,
next, yes.
sir, if we remove an option to add R2, comma 0 and remove last 0, then it is correct or wrong?
Which option you are saying?
In option 2, if we remove last 0, then it is wrong or right?
You are saying that ADD R2, comma 0 only.
Yes.
Okay, so here actually it is depends on how many operands are that ADD operation expect. Okay, so this is also depends on the instruction set, how the instruction set are using actually. So that the meaning may be different in the another instruction set. So suppose if you are using RISC RISC architecture, so that actually used in the different way. Any another instruction set may be different used in any another way. Okay, so here, so if this add operation require three that operands, so you have to pass the three operands.
Sir, so
Okay.
how can I understand that it is correct or needs that
No,
RISC-V
here
will
we are not
happen and
asking
any
here.
other operating system?
So that this here we are not learning this instruction set here in this course. Okay, so in some question actually in week 3, if we have asked this type of question, so we have given the that comments for the each instruction. So what is the meaning for that actually? So I think some yeah, you can see the question number 11 and 12. So why we have given this mention the comments, because we are not expecting from you that you know the meaning or the correctness of these instructions. So this may be changed the instruction set wise. So you can only read the comment and just understand the meaning of this instruction.
Okay, sir.
Okay, so here we are not learning this instruction set because this is separate computer architecture course where we just check this assembly language and this what is the exact instruction meaning. Okay, so this may be changed in the exact document or instruction set. Because of that, we mention the comments. Okay. Yeah, Mihir.
Sir, another conceptual doubt that I had. Can you please explain what exactly is the difference in an instruction set and instruction set architecture?
So that is also regarding the out of this scope actually instruction set And architecture, you are saying, okay.
Yeah.
Same thing. These all things are not actually from this course. If you are going in this in the deep, so instruction set actually defined for the programming language. So because every programming language have some that compilation process. Okay, so because the computer understand only this machine code, and machine code is what actually is, that is assembly language, which is very close to the machine, which actually processor understand. So machine, what type of instruction set is actually that machine is using for execution. So that some architecture is defined as a standard, so that like risk architecture is there. So another architecture is also there, so that actually contains the set of instructions, so that is called as a instruction set. The architecture is just a name of the that which standard actually used, just like this risk architecture, that actually have some defined the standard way to use the that instruction. So what should be the how many the number of operands should be there for the addition operation. So some rules are defined inside the that instructions standard, so that is actually called as a architectures. So rule and regulation things, which is
Okay.
okay, so which is actually provided by the that manufacturer who actually developed this
Okay.
instruction
Okay.
things. Okay,
Okay. Thank you.
yeah, but for these type of course, just wait for some that architecture course. Okay.
No, sir had mentioned
So
these two terms on a superficial level, so that's why.
yeah, because these topics are just sir have mentioned some basic idea.
Yeah,
So to understand all the things, you have to enter into the course, different course.
got it, got it.
Okay, so
Thank you.
like if you want to understand the operating system functionality or all these things, you have to learn the complete operating system course. You
Okay.
cannot understand all the things in one lecture of the operating
Yeah,
regarding the operating system. Okay.
yeah, I get it. Okay.
Mhm. Okay, so I think some another query is also there from, yeah, question number 7. You are asking that 7 or 8?
Yes, sir. 7 will be done.
7,
Okay, okay.
7, 8, 12.
Okay, fine. So this is representation. So here the this is that float value actually 1011 dot 0101. So this is the binary representation with the decimal, this with the dot value. So how we can calculate the uh, decimal equivalent for binary? So what you can do, you can write like this: 1011 dot 0101. Okay, now for this first value which is coming before the decimal. Okay, so that is actually comes as a 2 to the power 0. This 0 is started here. Okay, so 2 to the power 1, 2 to the power 2, 2 to the power 3, and on this side, after this decimal value, this will become -1. Okay, so 2 to the power -1, to the power -2, 2 to the power -3, and 2 to the power -4. Okay, now you can just multiply these things. So 1 into 2 to the power 0, so that means 1, plus 1 into 2 to the power 1, so this is 2, plus 0 into 2 to the power 2, so it will become 0, plus 1 into 2 to the power 3, so this is 8, 8 into 1, 8. Dot this side, you will get this negative thing. Okay, so that means 1 by 2, this is 0. Okay, so this will become 0. 1 into 2 to the power -2, so this means 1 by 4. Okay, plus this is again 0, we will skip this, and this is -4, so this is, that means 1 by 2 to the power 4, 16. Okay, now perform this: 8 plus 2 plus 1, 11. Dot, now here this side, 1 plus 4, 1 divided by 4 plus 1 by 16. Calculate this value. So that means 16, this is now 4, 4 plus 1, 5, so 5 by 16. Just calculate this value, what you are getting. So this is very close to this 3. Okay, point this decimal 3. Now 1, okay, so 4 and 3 like this, 2 then 5. So 3125. So that means 11.3125. So this is the answer. Okay.
Sir,
Yes, yes.
it is the way to approach decimal equivalent in binary numbers.
So you are saying that how we can calculate the binary equivalent for this?
Yes, yes.
So you can use division method, or you can use the same things like this, which professor have discussed this. You can figure out the value. Yeah, for decimal negative part, you have to check this. You can also perform the division method, check this, but this will be a little bit difficult to calculate in the decimal part. But for the positive side, you can easily use the division method. So like if you have this 11 value, what is the binary equivalent for this? So just perform the division method. Okay, so like 2. Okay, so when you are dividing this, 2 5 are 10, and what is the remainder? 1. Okay, again divide by 2. So again 2 2 is 4, and remainder is 1. Okay, then again 2. So now this is completely going 2 1 is 2. Okay, so 1, and remainder is 0. Now this is the only one value, so this will be used as a reminder. So 1 0, we will read this from bottom to top. Okay, so 1 0 1 1. So this is the equivalent binary for this 11 value. Okay.
Here we can take another base instead of 2.
So suppose if so this is we are calculating in the binary. Suppose if you want to calculate the 50 number in the octal. Okay, so 50 is given as a decimal, and you want to calculate in the octal. Like what is the octal representation for this 50? So in that case, one second.
Sir,
So here actually what you can do, you can divide by the 8. 58. Any pencil?
Sir, please scroll up.
You just wait. Power cutting. So here actually when we are dividing 50 by 8, so this we are getting 8 6 48. So 6, and what is the remainder is 2. And again now 6 is less than 8, so this will be the remainder. So 6 2. 6 2 is the octal equivalent of 50. Okay. So the same method we can use with any base to convert from decimal to any base number. So you can divide by the base value continuously and just read the value from bottom to top. This remainder value, bottom to top. That is the equivalent things.
Sir, last question you get 5 by 16 now, sir.
Which one?
5 by 16. At last 4 plus 1 is equal by 16 is equal to 5 by 16 you got, right?
Yes, this 5 by 16.
And how you convert it to 3125?
Just this divide now 50. This 5 divided by 16, you will get this decimal 3125.
Okay. Like we need
Okay,
to just divide it. That's all.
this is the simple division.
Okay.
Can
Then
you
we need
repeat,
to add
sir,
with
how
11.
we can
11
change the base?
point 3125. That's all.
We will use this 3.125.
so how we will identify the binary number after the decimal?
How to identify after the so what you are saying, I'm not getting.
So how we will identify the number after the decimal, that is 0101, that's having the 3125. So
Okay, this, yeah, same things like as
yes,
the
sir.
on
Yes,
this
sir.
side we are using this range 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. This side we will continue with the same range with the negative sign. Okay, so first is
Okay.
2 to the power -1, 2 to the power -2, -3, -4. And simply we are doing the same process, 0 into 2 to the power -1. So this will become 0 plus, okay, 1 into 2 to the power -2. So we can write like this.
Yes, sir.
Okay, plus
Okay,
this is
got it.
also 0, and this plus is this is. Now after that we are calculating only this division things.
Yes,
and
sir.
we are
Got
getting.
it. Thank you, sir.
0.3125, oh, sir. How we need to convert this is in decimal, right? How we can convert in octal or
Sir,
something?
No, what you're saying, zero,
Like 11.3125 is there, right? That
yes.
0 point like 0.3125, how we need to convert in other forms like octal and stuff.
Okay, you are saying that this part, this decimal part, how we can convert into a another form.
Yeah.
So first thing we have to understand the decimal thing. Suppose if we are that given like as a uh, 10.5. So how we can convert the binary for this? You are saying this?
Yeah, if it's in decimal, how we can convert in octal and
Okay. So let me check the same things. So 50 for decimal octal part we will perform the same things. So first we should understand the binary things. Okay, how we can represent to the binary things. So what method we can use? Same things we can use with the octal things. Okay. So for decimal part, so this is the decimal part, and let me think how we can get this 50. 450. Okay. So because here this side we have the negative representation. Uh, Decimal fractional part, the binary form. Okay, let's discuss the things. 10 separately, 55, 0.5. So I have not calculated this also. So this is actually typical because we have to calculate like this how we are getting this 50 equivalent in the form of like this. So 0.50 this part, how we can achieve this with the help of this uh, 2 to the power minus 1 minus 2 to the power minus 3 and 0.50. What should be the equivalent of this binary? Otherwise, decimal fractional part 50 if we divide by 2, that will not work. The fractional part. Okay, so yeah, right now I'm not able to recall this fractional part conversion of the decimal to binary. So, but yeah, that we will discuss this in the next session. Okay, but this is actually also not too much required things. But we will
okay, sir.
definitely discuss. Okay, in the next session because this calculation is actually complex, not very easy. You cannot calculate this
Like
easy because
they won't
we
ask the decimal form to convert to other
that's
form.
yeah, this type of calculation where the much calculation is required, that definitely we will not ask in the exam.
Okay, sir. Okay, sir.
Okay, but this process actually easy because here we are simply doing the same things as a positive side in the negative, but the reverse process is actually difficult.
Sir, for
Okay.
this question, can we say since 10.5, sir, point 0.5 is just 1 by 2, so can we say it is like 2 to the power of negative 1?
uh, so yeah, that we have to figure out. So yeah, you are correct. If we have zero point 0.5, so that means 1 by 2 is required. Okay, so yeah, we will get the zero point 0.5 things correct. But what happen if this value is like 5 2 3 8 like this? So how we can achieve this? This is difficult.
Yes, sir.
Okay, because we have to reach this point. So how we are achieving this, like 1 by 8 or 1 by 4, how we are getting this value by performing this addition. So this is difficult. Yeah, 0.5 is we can directly figure out that 1 by 2 is okay. So we are getting 0.5. But is there any way to find out this value easily that we will actually figure out and we will discuss in the next?
Yes.
Okay.
Sir,
Yes.
sir, I have a query. Like in first lecture of the week 2, sir was telling that we have more significant bit and less significant bit. Sir, what is the difference between that?
Okay, so most significant when we are writing this binary like 0, 1, 0, 1 like this. So least significant bit is called as this bit. Okay, from this right side. Okay,
Okay, sir.
and this is the most significant bit. So this is LSB and this is MSB.
Okay, sir. Got it. Thank you, sir.
Okay. Yeah. Okay, so this fractional part, I'll just look this any easy way, but I am not sure that the easy way is there or not. So we'll discuss. Okay, that 8 is done. Okay, it is not done. Okay. The sum of two unsaid binary number is this. If one of the value number is this, and what is the value? The other number. Okay, so here sum is given. Sum is given. One number is given. What is the another number? So this is actually unsigned binary number. Okay, so that means all digits are considered as a number, no sign bit. So what you can do, you can figure out, you can simply convert this number into a decimal number. Okay, and just check what is the equivalent. So what is the equivalent decimal number for this? This is binary number, and what is the equivalent decimal number for this? So 1011101. So same, just use the 2 to the power 0, 2 to the power 1, 2 to the power 3, 2, 2 to the power 3, 2 to the power 4, and 2 to the power 5, 2 to the power 6. So 1, okay, and here 2, 2, 2. So this plus 4 and plus 8 plus 16. Now this will become 0, and this is 64. Okay, so this is the equivalent decimal. So 64, 16, 80, 88, 92, 93. So this is 93, and same thing do with 101101. So 0, 1, 2, 3, 4, 5. So this is 1 plus 0 plus 2 to the power 2, 4, 4. Okay, 8 plus 8 plus 0 and plus 32. So 32, 40 and 44, 45. So 45. So this is the total sum. This is the one number. So just subtract this. So you will get 8 and 4, 48. So what is the equivalent binary for this 48? Just check in this. Okay, so you can use the division method or you can use SUR method. So like what value you're getting, which is below than this 48.
It's 44.
93 minus 45.
No, sir. Instead of 45, it will be a 44.
Okay, 1 second.
No, sir, it's correct.
So we are getting this one now. Okay, 48. So how we can represent this 48 2 to the power 5? So this is 32. We cannot take 2 to the power 6 because it will become 64, which is greater than this. So 48 minus 32, which is 8 and 8, 16. So that we can represent by 2 to the power 4. Then all will remain 0. Okay, so 2 to the power 3 and 2 to the power 2, 2 to the power 1 and 2 to the power 0. So this will become 0, and we will use only 1 for this bit. So this is 16 into 1 plus 32 into 1. Okay, so this one. So 1 1 0 0 0 0. So this is this representation. Okay, so you can perform this operation after converting into the decimal. And out then 12 to this one. So just perform the instruction as per given. Okay, so move R1 10. If you don't know what is the meaning of this, just read the comment. Okay, so here comment is given for instruction. So move the value 10 into the register R1. So we are using one register and 10 value we have stored in this. Next statement is move the value 5 into register R2. So we are using another register and we are storing 5 value initially. And another register R3 we are using and we are storing the 0 value in this. So this is the register we are using in the program. After that we are performing loop, start the loop, and inside the loop we have one instruction add R3 R2. So here what we are performing with the help of this operation, so add the value of register R2 and R3 and store in the register R3. So here what is the value of R3 sorry R2 and R3 last updated value. Okay, so 5 and 0. So 5 plus 0 5, and we will store this 5 value into R3. So that means this value will be updated by the addition. Okay, so R2 and R3 was 0, so 5 plus 0 equal to 0 5, and that 5 we are storing into the R3. So R3 value will be updated by the addition of the operation. Okay, now this is the update. Now DEC R1. So we are reducing one value in the register R1. So this will reduce to one value. So this will become 9. Okay. Now change loop, jump back to the start of the loop if R1 is not 0. Okay. So you can say R1 is not 0 in this condition. So we will jump back. So here condition is given. If this condition is satisfied, if this R1 is not 0, we will move back to the loop, first instruction. So same things we will do again for the 9 value. So what is the current value of the R2 and R3 now? So this is 5 and 5, both 5. And we are getting 5 plus 5, 10. And 10 value will be updated here. So 10. Okay. So now, once again, we will do the same things. We will reduce the R1 value. Okay. So, yeah. Okay. 8. And what is the value? Same things we will perform. Now we understand that what we are doing in the instruction. So we will repeat this process until we are reaching the 0 value in this R1. So now 5 plus 10, 15. So this will be updated 15. Okay. Now we will reduce to 7. So 5 plus 15 equal to 20. Now we will reduce to again 6, and 5 plus 20 equal to 25. Now reduce to 5. 5 plus 25 is equal to 30. Then reduce to 4 and 35. Then 3, 40. Then 2, 45. And then 1, so 50. Now still okay, so 0. So here you can see we are getting so 50, and after that we are decrementing 0. Now our R1 is equal to 0, so we will not loop back. So 5 in last, when we are stopping this code, what R3 value we are getting? So this is 50, last value. Okay. Is this okay?
Yes, sir.
Okay. So now all done. Okay. Next is Varun.
Sir, I wanted to ask if we can use references while solving the graded assignments.
Reference for what?
Like either from the given materials or certain doubts that we might ask outside.
Graded assignment, you are saying that because the questions are very similar to the practice assignment, and we are discussing the practice assignment in the session.
No, if we have a doubt or something, can we refer outside?
If you have any doubt, you can ask. So we can just discuss. We are not referring outside anywhere in the code, but yeah, we can discuss some logic things and concept things to solve like this.
Oh, okay.
But we are not using any reference material outside of this course.
No, like can I
You
Refer.
can use, yeah, you can definitely refer. We are not stopping any.
Yes, sir. Thank you.
Okay, Varun. Okay, any other query? Anyone please add the point question? Yeah, Pratap.
Hello, sir.
Yeah, hello.
Please reload your page. Which one? The last question.
Okay, which this one?
Yes, sir. Sir, R1 is 1 when R3 is 50. So R1 is 0, so R3 is 55.
No, but this loop will stop now. So here, what condition is given in the last? Jump back to the start of the loop if R1 is not 0.
Okay, sir.
Okay,
Yes,
you need to jump back if this condition is satisfied.
okay, sir.
Otherwise, you will stop. Okay.
Yeah. Okay, sir. Thank you.
Okay. 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 Any other query? Okay. Regarding this programming assignment, I hope you all are comfortable with the interface, because now we have also released one new UI. So I hope you know, for the programming assignment. Till now we were using the different UI. So like PPA1. So this is the old UI actually we are using, and new UI we have just released right now last week for the test. This is just in the testing phase. Okay, if you are getting any difficulty to inside the new UI, just move back to the old UI, this one. Okay, so in this I'm just repeating the things. I hope this is all discussed in the previous session also, but if anybody is not joined in the previous session, so regarding the programming assignment, you have this interface. Okay, this is the problem statement. So for each problem, just read the problem statement carefully first. Okay, so here what happened actually, just focus on the each line of the problem statement. Do not miss any constraint rule or which is given in the question statement. Okay, so after reading the problem statement, also see the sample input and output which is given in the problem statement. So here what is given in the this question actually. So complete the program to calculate the sum of the first n natural numbers. Okay, so this is natural number. So that means we will perform the sum only from 1 to n. If n equal to 5, so that means 1 to 5. So we will not include 0 or negative things, because these are the natural numbers. You are given an integer n, so this value will be given to you in the code. Calculate this the sum of first n natural numbers and store the result in the integer variable sum. So according to the statements, just perform the same things in the code. This is the input and output is given. So in this programming assignment, we have configured some input to the program, and your output should be configured correctly according to the programming problem statement. That is also configured. So what if you see the, if you want to write the code, you have to select the language first only by this choose language statement. So C, when you click on the C language, you can see this interface. Okay, this is actually a editor where you can write the code, but inside this editor also some gray part is given, some white line is you can see. So what is this gray area? Okay, this one and lower one, this is actually a fixed code. Okay, which is configured actually in the portal. This is fixed code, you cannot delete this, and do not try to delete also. Okay, you should consider this code in your program. You just need to complete this program. Some program code part is given to you, so this is called as a prefix. Okay, so the above gray part area is actually prefix, and this is a suffix. Prefix means initial part and suffix means the last part of the code. And in between there is one white line and cursor. You, when you click on this cursor, you can cursor is blinking. Here you can type anything. Okay, you can type, but you cannot type. You can, if you are clicking on the above line, you cannot type. If you are typing, nothing is happening. Or you can also Do not try to remove this gray code. Sometimes you will also find the code without in this gray area, so that you can edit. Okay, but this gray is actually a fixed code. This is a prefix, this is suffix, and you can write your code in this area, this white area. So this is just a configuration way what actually problem statement is asking. Sometimes you have to write the complete code as a fresh code. Okay, nothing will be given in the code, and you need to write the complete code. Sometimes some part of the code will be given, and you need to just look the given code and complete the code. Okay, sometimes some code is giving, some function is asking to write, so just perform the task according to the problem statement. What problem statement is actually asking, that perform the only that task. So here for this first problem statement, here you need to complete this code, and to understand what happening in this code, should know the meaning of the every state, each line of the code. Okay, so this is the header line, header of the code, because inside the function, inside this program, we are using some function directly. This scanf, this printf, these are called as a function, which is comes with this open bracket and close bracket after some this naming. Okay, so this is called as a function. Function is just a block of code that performs some task. So we are passing some value inside this function, and that function will perform some things, okay, internally. And the work and the meaning of this function is defined in this library. Okay, stdio.h, standard input output, this header or library. Okay, so this library we generally include in the code, because most of the time we use this input function or output function. So input function means here by this scanf function we read the value from the console. Okay, console is just a interface where the user actually interact with the program. Okay, so at the run, when the program is running, you can pass the value to the program. So how you will pass that value will be passed through this function. So this will read your value at the running time, and this printf function is just return or print the value in the console, which user can see. Okay, so this statement for which is used for the output means the some value will be displayed in the console area. Okay, where you can look that value, what value is actually printing by the code, and this is just reading the value from the console. Okay, so reading the value means input of the code, and this printing the value means output of the code. So input and output we give for the every problem person. Okay, so we will give some input to the code. This should be the output according for this input. For input 5, this should be the output. Okay, and some public test cases are configured. So this public test case doesn't have any weightage in the marks. This is just for your testing. Okay, you can just see that if input is 5, expected output is 15, and what your code actually is returning, that output will come here, actual output. Okay, expected means this output should be come for this input, but what your code is returning, that will come in the actual output. This actual output and expected output should be exact match. Okay, so you cannot include a space in before that and in between 1 or 5. That output should be exact similar, that should be exact match, then your test case will be passed. Okay, so these are public test case. You can see the input and you can see the corresponding output, and according to that you can just write your logic in the code. And if you feel that your logic is correct and your logic will return always correct output for any input, okay, then you can go for the private test case. So private test case is also very similar to this. Input and output value is configured for the private test case, but that you cannot see. Okay, so marks are allocated only for the private test case. If your logic is correct, that means private test case will also be passed, and your marks will be allocated for these private test case only. Okay, why these private test cases are hidden? Because what is actually possibility, if you can see the input, you can print the output using the condition. you can simply use the condition if this is the input, uh, this should be the output. If you are able to see the print, that input and output, you can directly use the if else statement, and without using any problem statement logic, you can just print all the output according to the input. Okay, so that is actually not the required things. So you should know the logic of the problem. So because of that, private test cases are hidden. Here you need to write the correct logic according to the problem statement, then your private test case will also be passed. So for this program, so what is the process to solve doing the programming assignment? So here you need to complete this program to calculate the sum of first n natural number. Here in the this main function. Okay, so after this include stdio.h, we are including this is the main function, which is the required function for the program. Compiler always looks first for this main function. Okay, so this is the main function. Compiler always entered into this main function first. You can also write another function in the code, but compiler always looks first main function of the program and enter into the main function. So what is the first statement for the main function? That will execute first. So this main function is required in the program for every function. Sometimes this main function definitely code will be given and you need to write the another function. So that will come later in the week 5. But here, yeah, this is the main function. After that, this all statement will execute one by one. So what is the meaning of all statement? So here int n. Okay, so we are declaring a variable n, and what is the type of n is integer. So that means we want to store some integer value for this n. Okay, and after that we can use that integer value with the name of n. Okay, so this is called as a declaration. We want to use some variable name and we want to store some data into that variable. Okay, this variable is just a identification of the memory. Some memory location is assigned to this variable name, and inside the memory locations data is actually stored. Okay, but you cannot use the memory location every time in your code because this is not human convenient. So what you can do, you can write the variable name which you can easily understand. You can give any name like age, name, that is actually human understandable. So here same things, you can give any name for the variable which you can easily remember or understand. So but by default the compiler will allocate some memory for this and the data will store inside the memory, and the linking will be happen for this name and address, memory address. So here you have declared a variable n, and this is the type of int. In the next line, scanf %d and n. Okay, so what is this? And scanf function used to read the data from the console. Okay, and inside this function what we are passing this and symbol n. So what is the meaning of this? So this n is just a same variable which we have declared. Okay, and this and is return a address. Okay, this is used to return the address of n. Okay, so this is the means we want to store the data of this n address. Okay, what are the that address of this n? We will store the data at that address. So this is just to represent the address of n. Okay, and what type of data we are reading? This is a specifier, type specifier. Okay, so d means integer, and this is a that formatting. So what type of data we are actually reading? So that we have to declare in this with the double quotes. So %d means integer. If we are writing %c, so that means character. If %f, f means float. So these are the just representation for the data type. Okay, so this is the required things to read the data from the console. So some value we will read, so like this input 5. So what is the meaning of this? 5 will be passed in this n for the n. Okay, after that you need to calculate the sum of first n number, and then this statement is actually printing the sum result. So this sum value you have to declare this because this sum is not declared in the code. What is the type of this sum? If you are adding first n natural numbers, so definitely you will get the result in the integer form, because if you are adding 1 + 2 + 3 4 5 like this, definitely you will get the result into the integer form. So first step, what you can do, if you are using any variable which is not declared in the code, so first you have to declare that variable. So that means this sum should be declared first in the code, and the type of this sum should be the integer. So what you can do, you can write the int sum. Okay, so int sum. Now this is the first statement. Then you can press enter and you will get the next line. Okay, so int sum. After that, how you can calculate the sum of first n natural number? This logic you should know. So there are two way. One, you can do this task using the loop, but loop is not discussed. Okay, so you want to calculate the sum of 1 plus 2 plus 3 if n equal to 5. You want to perform these things. Okay, 1 plus 2 plus 3 plus 4 plus 5, all number of this. Okay, 1 to 5. So how you can performing these things? So mathematically there is one formula. If n equal to 5, you can directly get the solution like n into n plus 1 by 2 directly. If you write this equation, you will get the sum of this 1 to 5. Okay, so n equal to 5, so 5 plus 5 into 6 divided by 2, 3 and 15. Okay, so you can see 1 plus 2, 3, 3, 6, 4, 10 and 15. You are getting 15. So this formula you can directly use. Otherwise, you can also use the loop. Okay, but loop we will discuss in the week 4. So that time we will discuss the solution using the loop. Okay, so I am not using the loop syntax here. So what we can do, we can directly use this formula in our code. How we can write this formula in our code? So we will use the operator which is defined in the language. So sum equal to. Okay, so sum equal to. So we will store the result in the sum. Okay, and what should be the formula? N into. So for into, you cannot write like this. Okay, so also remember this, n plus 1 like this. Okay, you cannot write like this here, because here there is nothing is mentioned here what is operation performing with this n and bracket. So by default compiler will not understand this operation, so n bracket this. Okay, so you have to specifically mention that multiplication operation here, n into n plus 1 divided by 2. Okay, and for complete the statement you use this semicolon. So this is the equation we have written. Suppose if I use the incorrect equation, so like -1. Okay, now I feel that my code is complete because I have declared the sum variable. Now I have allocated the result by calculating this equation to the sum. Okay, so the result of this equation will be assigned to this sum variable. At that value we are printing inside this function. So the print statement also print the strings which is represented by this double quote, and inside this double quote we can pass the value of the variable with the help of this specifier. Okay, we can also write some strings statement here, and at the place of this %d, this variable value will be passed. Okay, so that value will be print. Okay, and return 0, this last line is actually a indicator to the system, return 0, because we have mentioned this function return type int. Okay, so this is actually return type, this is function name, and so function should be return some integer value. So here we are returning 0, and this is this main function return value is actually just an indicator to the operating system that that operation is finished successfully without any error. Error means any system error here, not the code error. Okay, so this 0 is just for the indicating to the operating system. Yes, someone is asking something. Yeah, Adit.
So I was just asking that instead of return 0, we can use any other digit like return 1, return 5, anything?
No, for main function, do not use 1 because that will be the different meaning for the operating system. So 0 means successfully, 1 means something that problem is happening during the compilation, that running process. So
Okay.
here do not use this return statement 1 or 2 anything for the code.
And sir, if I use void instead of int main, void
You can
means
use void. You can use void. Then you no need to return anything. Okay. So if you use void, don't you no need to return here. But this is just a indication for the operating system. That means your code is successfully run without any that system error like this. Yes, Srinjay.
Yes, sir. Can you explain the fifth line again?
So line number, this is scanf.
Yes, sir.
So let me discuss here. Okay. Okay, so this is just a simple basic structure of the code. Okay, and suppose we want to read some value from the console. So the right side you can see this console area. Okay, so you can see on the top console. Okay, this is just a interaction point to the program. Okay, here we can interact with the program at the running time. So to reading the value from the console and printing the value to the console, we use this scanf and printf function. So for reading the value like int, we are just using n. Okay, so we want to read the value for n at the running time. When we run this code, we want to read the value for n. So we will use this scanf function. So scanf, and this scanf actually required first thing is the type. Okay, and so this type means what type of value we want to read for n. So we want to read the integer value because this n is defined as an integer in our code. So for integer representation, we use the specifier %d. This is specifier for the integer. And after comma, we just mention that what is the address of n. What is the memory address of n? To point out the address of n, we use this and symbol and n. Okay, so now that means we are indicate that scanf. This is indicating that when we will run this code, our this compiler will stop the running at this statement. Okay, and will wait for the input from the console. And when you pass the input, that input will be stored in the at the address of this n and will saved for the n. Later you can use that n value for any purpose, like you can increment the value of n. So like this n equal to n plus 2. Okay, and after performing the operation, you want to just print the value. So print f, and that you can just write any statement here. So updated, we have updated the values. We have updated the value of n2. Okay, now we want to pass the new value for the n here at this place. Okay, n2, this place. So what we will do, we will use the specifier here. So %d, and for this %d, we will pass the variable name, so that n. Okay, so this is the statement for this printf, print 50. So what will happen actually, this strings, this is actually strings which is written inside the double quote, will be print in the output, and at the place of this %d, this value of n will be pasted here. Okay, so this %d will be replaced by the value of n. Okay, so now if we run this code, so you can see now the execution is stopped at this line. Okay, nothing you can see in the output screen. Okay, this is just only indicator. So our execution is stopped at this point. Now it is waiting for our input. Now we can just pass an input like 5. Okay, so when I type this 5 and when we press the enter, so this execution will start. So that 5 value will be stored inside this n memory, and later we are performing this n equal to n plus 2. So the what is the value of the n is 5. 5 plus 2 will be performed 7, and 7 value will be stored at this n. So that means the value will be updated by the 7 of this n, and that value we are printing here. So when I press enter after giving this value, so you can see the next line is actually this operation is executed. Now this statement is actually executed. So this statement is actually printing some output into the console. So this, you can see this percentile d is actually replaced by the value of n. So this is 7. Okay, so for every code we are we are passing some input with the help of this scanf things, and we need to print some output to return the output in the for the program. So in the code you can see, uh, okay, so this is the code. Now suppose we feel that this code is correct. Okay, so we can run this code, test run. So for test and click, actually this public test case is passed. Only public test case is executed only. Okay, private test case which are hidden, that will not execute for this test run button. Now for public test case, you can see your output, what your code is actually returning. Okay, so here you can see public test case 0 out of 5 passed. Why this 0? Because your actual output is not matched with expected output. So here you are getting 10, but here this is 15. Okay, so same things you can do. So here output is not matched. So that means some logic is not correct. So what we can do, we can correct the logic and like plus. Okay, now change the logic and again test the public test case. So now you can check the status is changed. 5 out of 5 passed. Now you can see the value is also exact same. Because of that, these two values are matched and your test case is passed. If you feel that your code is correct, then click on the submit button. So this submit is required for your marks. Okay, so do not skip this submit button, because private test case should be run. So you can see the status lower side, submission successfully, 5 out of 5 private test case passed. So your marks are equally weighted for the each test case of the private. If 5 test cases are there and the marks is for every question is 100, so that means each test case weightage is 20. Okay, so you can also expect calculate your marks for the programming assignment, how many private test cases are passed. So, and also your last submission will be considered for your marks. So suppose if you have written the code and it is working fine, and later before the deadline you have changed the code and that code is actually not correct, so the last submission will be considered for your grading. If that is incorrect, you will lost your marks. Okay, so first submission will be ignored. So also just submit the correct code as a last submission for the assignment. So this is just
so here we have not given any input.
Yeah, input is given similar to this public test case. Input is different. So suppose here 5, 10, 8, 20, 100 is 200 is given. Similarly, private test case is also there, but the value will be different, but that you cannot see. Okay, but if your logic is correct, that will also pass the private test case. Okay, so this is old UI. This is you have to scroll too much. You have to, for the problem statement, you scroll up, then you have to scroll down to see the status. Now the new UI actually is created where you can see the problem statement on the left and you can write the code on the right. So just use this also, and this is just in the beta phase testing. Okay, here you can see the new interface. Okay, so you can just hide this menu like this, and in this UI you can see the problem statement on the left. Same times you can write the code on the right, and here you can increase the font and decrease the font like this. Some feature are not enabled right now, so the like debug feature is not enabled. Test case you can see, but solution you cannot see before the deadline. So here indication you can see, read the problem statement, write the code here, and test run is the same. Okay, so same for the public test case. When you click on this test run button, so that will actually perform the public test case. So public test cases are, you can see. Okay, so input is 5, our expected output is 15, actual output is 15. You can zoom also, like you can see in this way. Okay, and for each test case you can see by the clicking on this. For private test case you cannot see. You have to click the submit button, that this status will be updated. Okay, so submission successful, 5 out of 5 private test case passed. Okay, so you can see this message, or you can also see the status below the problem statement. So this, how many public test keys are passed and how many private test keys are passed. So this is just an indication, last submitted date of this. And after deadline, you can also see the solution in this tab. Okay, but so this is the new interface, and you can zoom this. Okay, so you can, this user interface is more friendly and more closer to the that competitive platforms, another like this Geeks for Geek, Lead Code, these type of platforms. So just try to use this for your convenience. Okay, so
Okay.
yeah, yeah, this is the things. Okay, so just remember this shaded thing. Sometimes you will see like this, you are not able, we have received actually lot of time this type of complaint that I'm not able to write the code. So actually what happened is to try to write in this gray area, but this is not, this is actually fixed code, you cannot update. So just write in the white area, you cannot write the later because this is suffix code. This is the only area in the middle part, you need to complete this code. So just type here and enter to write the next line like this. Okay, you can complete this. For some problem statement, you will find out that the all white space. So like, let me check PPA4. So here you can see nothing is given. Okay, so this is totally fresh, a totally white area. So you need to write the complete code for this code. Okay. Some code is given here, so you need to complete this. So based on the problem statement, just write the code. So here this is also need to complete here PPA7. So here this is totally empty. Okay, so you need to complete the code. So here some code template is given here. Okay, so what you can do, you can copy this and you can paste here. Okay, just read the statement and complete the code. If you so some statement template is given. Okay, so in this way you can just try. So just so use this, do not forget this submit button. Okay, so this is actually required for the marks. Yeah. Okay, so yeah, this is regarding programming assignment. If you have any problem, you can also post on the forum. So apart from that, any query? Okay, so Has.
Hello, sir. So I had a small query. Like, once we submit a code and suppose one of the private test cases fail, so can I edit the code and submit again?
Yes, yes. So that is required actually.
Okay.
So that means if one test case is not passed, suppose 5 test cases are there and 4 is passed, 1 is not passed. So that means your logic is actually is not correct for the every corner case.
Okay, sir.
Okay, so you need to update your logic and correct the code and run again. Click on the submit button again.
Okay, so latest submit button will be considered even
Yes,
in the
yes.
graded ones.
Yes, yes. So last submitted code, last submit status will be considered.
So you can submit infinite number of times before.
Yes, yes. Before the deadline, you can submit any number of times.
Okay, that's it. Thank you.
Okay. Okay. Any other query? Yeah, we are also planning some more session. Okay, that we have had one TA. So I think maybe on Wednesday or Thursday, I am updating the schedule on the calendar, and one session on the Sunday. Okay, so 2 session we are planning for to increase from this Week-3. So you just also join that session for your one session we will dedicate it for the programming assignment to preparation for the OPP exam. Okay, so online proctored programming exam. So that is only for focused for the programming questions, and one session will be like as an open session where you can ask your doubt. Okay,
what is OPP?
Online proctored programming exam. So that will be for the our foundation student, not for the qualifier. Okay, so those who are actually qualifier students, you need to just pass first this qualifier exam. If you enroll into the course to continue, so there is one exam actually that will held after the week 6 or 7, that is programming exam, and you have to qualify that, clear that exam to pass this course. So that is actually you have to join through the Gmeet. and some proctor will monitor you, and some programming question will be there, and you have to finish that these programming question in given duration, 2 hours duration, and 4 programming questions. For passing, you have to clear at least 2 programming problems. Okay, so we have 2 programming exam for this course. Okay, so first OPP will be held after week 6 or 7.
Sir, but it is only for the foundation
Yeah, only
one.
for the foundation. Those who have enrolled in the course as a term student. Okay.
Okay.
Those who are qualified students, suppose if you qualified and you want to continue the same course in the same term, current term. Okay, so that you can enroll into the course, and that OPP exam will also applicable for you.
Okay, sir.
Yeah, Shiv Kumar.
Sir, one question, sir. If there is in the exam also same interface will be there,
Yeah, same course interface which you are now seeing.
Okay,
Same
okay.
interface will be there.
In the qualifier,
Okay.
because the qualifier exam we need to go to the one of the center and attend. In there also we'll find the same, right?
No, qualifier exam, the interface will be different. Okay, that is actually they will use the TCS interface.
Okay, you have any sample of that, sir, to show us?
That is if you have given any like competitive exam on the TCS, that is similar to like this competitive exams.
Okay.
So questions will be there, then option will be there. You need to select only the correct answer.
Okay, but
programming exam will be happen in your system actually. You have to join the exam session with your laptop. Okay, and that browser or portal we will use, which currently you are using for the course. Same portal we will use during the exams, but the proctor will monitor you.
But not for the qualifier.
Yeah, qualifier is just a MCQ, MSQ type exam.
Okay.
That programming exam is actually a coding exam.
Okay. That starts from the foundation, you mean to say?
Yeah, that will start for the foundation. So to clear this C course as a foundation student, you need to clear one of the programming exam with at least 40 marks. And there is some criteria for the theory exam, so that you need to clear. So that all information is given in the grading document.
Okay, thank you.
And also for the foundation student, we will also start some timed assignment, timed lab assignment from the week 5. Okay, so that will actually helpful for you for the practice in the timed manner. That we will discuss later after the week 4. Yes, Suhas?
Sir, will the questions in the qualifier examination be in the same pattern which are being asked in the graded and non-graded assignments?
Theory assignment, graded theory assignment and practice theory assignment, similar type.
So similar type MCQ will be given and we need to choose one of them.
Yes. In qualifier, the pattern will be same.
Okay.
Sir, I had a doubt regarding some other course, but we don't have any live sessions of that course before the deadline. So what should I do?
Which course?
ESTC, Electronic System Thinking Circuits.
No, it is not possible. Before the deadline, definitely sessions should be there for every course.
No, tomorrow is the deadline, so there is no live sessions before that.
Okay, tomorrow is the deadline. Definitely, some session is already happened in the previous week, either Saturday, Sunday, or maybe.
Actually, I didn't attend some of the sessions.
Okay, so just like I think you are running late and for the asking query. So I think maybe two sessions are there for the ESTC.
Yes.
Okay. Yeah. So now you can ask in the next session, or you can contact with the help of forum now. So forum you can use.
So like I have shared my doubt in the discussion forum, but no one has answered it yet. So
you are qualified student now?
Yes.
So you are using some Google group, correct?
Yes.
Okay. So nobody is answering on the forum?
Nope, not until now.
Okay, I'll check. So I'll just inform to the ops team, so they will inform to the team. So someone will be checked.
Thank you, sir.
ESTC, okay. Okay, so just also join this TA session. Okay, so the TA will help you. So that the TAs are also actually students of our program. So they have already learned this course sometimes before. So you can interact with him. You can ask your doubts. You can practice with him. Okay, for the programming. Just someone raised the hand. Oh.
Sir, the syllabus for quiz one for C programming is first for week.
Yeah, first 4 week.
Okay, okay. And in that exam, programming questions will also be there, or it will be just theoretical?
No, for quiz one, only this theory type of questions. So like this theory assignments for week. No programming coding questions is required. Questions will be there related to the programming questions. So like some code is given, what is the output? Some this type questions will be there, but you don't need to write the code in the exam.
Okay, sir. Thank you.
Yeah, that.
Sir, range of values in like 8-bit notation. It is a complement.
In 2s complement.
Yes, sir.
Okay. So.
And also, sir, the signed and unsigned ranges.
Yeah, I've initially in the first things I have discussed these things in today's session. You joined late.
No, sir, I joined it, but like I don't get the proper idea, sir.
Okay,
Asking
okay.
again.
So signed means that value if you have any value with the sign. Okay, so like -10, +10. Okay, so if suppose if you are using any variable where the variable is supposed to store the both type of both signed value, maybe negative or maybe positive. So you have to use the signed variable that data type. Okay, but if variable is all if you know that if your variable will always store the positive value, so you can use the unsigned value. Okay, so like age is the correct example, so no negative meaning value for this. Okay, so the age cannot be possible for like -1 -10. Okay, so for this type of variable you only need to store the positive value, so you can just use the unsigned data type. So how we can this value is actually represent signed value and unsigned value. Okay, so suppose if you want to store only signed value, so signed value can be represented by the 8-bit sorry, unsigned value. So suppose if you want to store unsigned, there is no sign for this value and you have 8-bit for this. So that means all bit can be used for the value magnitude. So that the range for that will be 2 to the power 8. Okay, so that means you can store different 2 to the power 8 value where there is no bit is assigned for the sign. And what is the value for this is? So 0 to 255. Okay, so total value are actually 256. 2 to the power 8 equal to 256. So that the range will be 0 to 255. So all these value you can represent with the help of 8-bit. Okay.
Yes, sir.
So this is for the unsigned range, unsigned value range. So you can use the all bits for the magnitude. But for the sign magnitude, suppose sign where the negative and positive, this information is also required to store. What is the sign for the value? So you have to use 1 bit for the sign. Actually, suppose if you have 8-bit, what you can do, you can use 1 plus 7-bit. So 1 bit for sign representation and 7-bit for value. Okay, so this means for 8-bit representation you have to use 1 bit for the sign and 7-bit for the value. So 1 bit for means 0 for positive and 1 for negative. Okay, if this first bit is actually 0, that means this is number is positive, and if this first bit is 1, that means number is negative, and remaining 7-bit will be used for the value. So what are the range for 7-bit is actually 2 to the power 7 you can use, like this is 128. Okay, so 128, so that means range will be assigned like this 0 to 127. Okay, so that 0 means what will be the first number, like 0, 1 bit we will use, first bit we will use for the sign. Okay, and remaining 7 bit we will use for the uh, number. So 0 0 0 0 0 0 0. So this 7 bits actually for the number and 1 bit for the sign. So this is representing positive. And the last number, this 127, is equivalent to 0 and 1 1 1 1 1 1 1. Okay, so this is the equivalent for 127. Okay, and this is for the sign positive. Okay, so 0 to 127 we can represent this range with the help of this 8-bit representation. So 8-bit, only we are only using the 7-bit for the value. So the range, positive range, will be this 0 to 127. And what will be the negative range for this? For
minus
negative,
128.
so here there is the problem actually. We have one value, this one. So suppose we have this 1 and 7 times 0, 5 6 7. So what is the equivalent value for this? This is representing the negative sign, and this is same things is representing the 0. So that means we have the representation one more for 0. So this is actually negative 0. Okay, this representation was like a positive 0, but this is like a negative 0. But this is not a correct things for the number. Okay, there is no meaning for negative and positive for 0. But we are getting one representation for this in this representation. Okay, but for the remaining range will remain same, -1 -2 like this. So same things, so minus, and so total 127. Okay, so that means this number will be represented 1 for sign negative and remaining will be 127. Okay, so this is 127 and this is the first representation, -0. Okay, so range is, we can say that for if we are using only this simple representation, sign magnitude representation. So we have for 8-bit we have the range 0 to 127, and this side also one this minus 127. Okay, but we have two representation for 0. One is positive 0 and negative 0, this range. So that means we can represent this range for the 8-bit binary representation for sign magnitude. Same things you can use the, like if you have 4-bit representation, so 1 bit you can use for the number representation, sorry, a sign, and 3-bit you can use for the number representation. So what will be the range? So 0 to, so how many bits you can represent with the help of 3 bits? Only 2 to the power 3, 8. So 0 to 7. And another range, negative range, will be -0 to -7. So this is for the negative representation. So this is the actually correct, not corrected. The another representation we use where we ignore remove this problem. Okay, so that is actually 2s complement. 2s complement representation. So in that representation we use the same positive side. Okay, so same things if we have 8-bit representation, so we can use the range 0 to, same things, 1 bit will be used for the negative 0 and 1 first bit. Okay, but 7-bit will be used for the value. So for 7-bit, that means 127 is the last. Okay, so this is for positive side. So this will calculate as it is, like is the previous number. So suppose if you have a minus 15, sorry, positive 15. So what will be the representation for this? So because this is positive, so first bit will be 0. So here I am writing. So what is the equivalent 15 binary is 1 1 1 1. But for 8-bit representation, we will complete this by 0 0 0 0. So this bit is representing the sign positive. Okay, and the remaining bit is representing the value 50. Okay, so this is like a representation, simple representation we can do, convert into the binary and use the 0 sign for the as a first bit for the positive representation. But for the negative representation, the same -15. So we use the 2s complement for the positive this value. So what is the 2s complement for this 15 binary value? So the what is the value for 15 is this. Okay, so we will write this 0 0 0 0 1 1 1 1. So this is the equivalent to 15, and we want to convert this into a negative 15. So what is the equivalent 2s complement for this? So we will convert into a 2s complement. So the process of the 2s complement conversion is first convert into a 1s complement. So 1s complement where we convert all the revert all the bits. Okay, so like 1s complement, so that is just a 1 1 1 1 0 0 0 0. I have revert all the bits. After that, convert into a 2s complement. You need to add 1. So just add 1 into this last LSB, least significant bit. Okay, so 1 plus 0 1, and so this is binary addition. Okay, so 0 plus 1 is 1, and remaining bit will be like this 0 1 1 1 1. Okay, so this is the 2s complement of 15, and this is representing a negative 15. Okay, so this first sign bit is representing the negative sign, and this number is actually representing a 15 in the 2s, that 2s complementation. So here you will not get the two representation for the 0. Okay, so for 0 you are getting this 0. So you are getting 0 0 0 0 0 0 0 0. Okay, so this is only for the one sign, because we don't have the negative 0. Okay, so there's no meaning. If you want to calculate the -1 value, so that means you need first the value equivalent for the 1, 0 0 0 0 0 0 0 1. Okay, and what is the 2s equivalent for this? So that is convert 1 1 1 1 1 1 1 0, and add 1 for the 2s complement. Okay, so 1 1 1 1 1. Okay, so this value is actually representing a -1. Okay, so this is negative sign for here, and this value is actually representing a -1. So here we are representing the numbers in 2s complement, where we are not getting the different representation for any value. For two value, we are not getting the different representation. So what is the range for this? So that means 0 to 127. Okay, 8-bit binary representation. So this side we can represent 0 to 127, but this side, that means there is no duplicate representation for 0. So that means we will start from -1 -2. So that means again we can represent 128 value. Okay, for 7 bits. So here the range is starting from -1, so that will reach at the 1 minus 128. So this total number of bits are actually 128. Okay, here this range is actually contain 128. So for 2s complement range, here 0 to 127, but -1 to -128, this is the range. All can be represented with the help of this 2s complement notation. But in the previous notation, so this range was 0 to 127, and another is -0 to 127, -127. So this 0 was actually repeating, but here it is not repeating. So we are adding this duplicate representation on this side, one more, 128. Okay, so what will be the equivalent of -120? So that will be actually this 1 and all 0. Okay, so 1 2 3 4 5, yeah. So this is the value. So this is for negative sign, so -1, and this value is actually representing a 128 in this 2s representation, not 0. So here actually we are getting one more bit, more value utilization. Okay, so same things you can do with 16-bit. If 16-bit is given, so that means 1 bit for the sign and 15-bit for the number. So you can calculate like this. So 2 to the power 15, what value you are getting, and the range will be like this. So 0 to 2 to the power 15 minus 1, this is positive, and this side -1 to 2 to the power 15 in negative. This is the range for the negative in the 2s complement range. Okay.
Sir,
Yes.
sir, it is 2 to the power 15 minus 1. Minus
No.
1 is in power or in base?
No, this is not in power. This is in the base. So after calculating this value, then minus 1.
Okay, sir.
Okay. Okay, sir. So this is the range things calculation formula. Okay. Okay. Any other query?
No, sir.
Okay. So
So
just
I have a doubt in question number 9 in graded assignment.
which week?
Week 2.
Okay, question 9B2. Graded or practice?
No, sir, graded. So it is written 5 numbers. So in which format? In it is in hexadecimal or decimal or octal?
No, 5 numbers means you have different 5 numbers, 5 different values you have, and you want to represent that value. You want to just map that value with the help of by bit number, the number of bits. Okay, so here means you have I've already explained this before in the initial session. But suppose if you have 15 different numbers, okay, so 15 different numbers. So how many bits are required? Or we can say that 20 we have 20 bit different numbers we have, and you want to map these different numbers with some binary representation. Okay, we are not calculating the binary value for this, but we just want to mapping some binary information. So suppose at the place of number we can see that we have 20 characters. Okay, so a b c like this, and we want to just assign some binary number for that every character. So how many bits are required actually? How many minimum bits are required to represent this? A B C D E F G H, like 26 characters we have. So A to Z in the capital letters. So we have 26 characters. Now we want to just map each character with some binary digit. So how many minimum bits are required to represent all the binary this A to Z numbers separately? Okay. So how we can calculate this? So we can calculate this with formula. So like 2 to the power 5, we can calculate how. So this 5 is actually representing a number of bits. So 2 to the power 1, that means if we are using 1 bit, so we can only represent 2 number. Okay, 2 number. So what that number is possible? So 1 bit we are using. So the value of that 1 bit either 0 or 1. So that can represent 2 different numbers like A and B. Okay, or we cannot assign any value for this bit because bit can only contain 0 or 1. If we have 2 bit, 2 to the power 2, okay, so we can total we can assign 4 different characters or numbers for that. So 4. So that means we are using 2 different first bit and second bit. So like we can change like 0 0 0 1 1 0 1 1. So these 4 combination are possible for 2 bits, and like A B C D 4 value we can assign for this each bit. Okay, so each value are actually unique, and we can use this unique binary combination for single character. So now total 26 character, how many bits are required minimum? So if we use 2 to the power 4, we are getting only 16 maximum possible combination. So that means we cannot represent 26 character with this help 4 bits. Then we will check this 2 to the power 5. Okay, so 5 bits we can represent total 32 characters separately. So that is actually fulfilling our requirement because we have 26 which is less than 32. Okay, so that means for 26 we need at least 5 bits, and with the help of 5 bits we can uniquely created the binary code for each character 26. Okay, so this is the minimum bits
Good.
required. Yeah, this is the minimum bits required to represent this 26 different characters. Same things we are saying for numbers.
Okay. Thank you.
Okay. The difficulty level of the qualifier will not be too hard. Okay, so if you are doing all the assignments question by your own and you understand all the concept clearly for the each question, definitely you can also solve the qualifier questions. So the level will be similar. Okay, so maybe this week I'll check tomorrow or maybe Thursday. One more session we will conduct, and Sunday one more session we will conduct. So 2 sessions we are all more increasing for this programming purpose for the TA session, and that session timing will be in night for maybe tomorrow or Thursday, but in Sunday maybe in evening, like 2 to 4 or 4 to 6. We'll check this. We will schedule this session in the calendar, okay, and we will also send the announcement. So also join that session. Okay. Any other query, or we can close? No query. Okay. Then just cover this week 3 content, because the qualified syllabus is still week 4. So do not skip any content till week 4. Okay. So cover this week 3 things, and Friday instructor session we will discuss the practice theory question of all week 3, and Saturday instructor session we will discuss practice programming assignments, and the TA session also we will discuss the programming assignments and what, if any topic if you want that we will discuss. Okay, Sunday or okay. Okay, thanks everyone.
Thank you, sir.
Thank you, sir.
Welcome. Okay, bye.